Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Agent-Based AI, Building Autonomous Systems. Before we dive into agents, let's quickly remember what AI is. At its core, AI is about making computers smart, enabling them to think, learn, and solve problems like humans. Or even better. But how do we build that smartness? Today, we're exploring a powerful way called agent-based AI, which lets us create individual, smart entities that can operate on their own. Think of it as giving your software its own mini-brain and a sense of purpose. Imagine you have a super smart robot butler. What does it do? It looks around your house, sees a mess, it thinks about what to do, decides to clean, and then it acts. Starts vacuuming. That's essentially what an AI agent is. An entity, be it a piece of software, a physical robot, or even a character in a game, that perceives its environment, makes decisions, and performs actions. It's autonomous, meaning it can operate by itself without constant human instruction. Every AI agent follows a fundamental loop, much like our robot butler. This is the core logic you'd implement as a developer. 1. Perceive. Sense. The agent gathers information from its environment. For a robot, this could be camera input or temperature sensors. For a software agent, it might be reading data from a database, listening to user input, or checking stock prices. 2. Think. Process. Decide. Based on what it perceived, the agent processes this information and decides what action to take. This is where the AI part often comes in. From simple rules, e.g., if temperature greater than 25, turn on AC, to complex algorithms or even a mini AI model. 3. Act. Execute. The agent performs an action. This could be moving a robotic arm, sending an email, updating a user interface, or adjusting a system setting. As a developer, you're writing the functions that handle these actions. Not all agents are equally complex. We can build them with different brain power. Simple reflex agents. Like a thermostat. If it's hot, turn on the AC. No memory, just react to the current situation. Developer. Think if else statements. Model-based reflex agents. These have a basic, internal model of the world. They remember past perceptions to understand the current state better. Developer. Adding state variables or a simple memory buffer. Goal-based agents. These agents know what they want to achieve. E.g., get to the destination. They plan a sequence of actions to reach that goal. Developer. Implementing planning algorithms or decision trees. Utility-based agents. These are the smartest, aiming for the best outcome. Not just any outcome. They weigh different choices based on how good they are. E.g., a trading bot trying to maximize profit. Developer. Involves optimization and complex evaluation functions. Agent-based AI is incredibly useful for building systems that need to be autonomous and adapt. Here are some real-world examples. Smart homes. Your smart thermostat is an agent. It perceives temperature and acts to control heating, cooling. Gaming. Non-player characters. NPCs. In video games are agents. They perceive the game world, decide where to go, and act, attack, hide, converse. Traffic management. AI agents can optimize traffic light timings by perceiving traffic flow and acting to reduce congestion. Financial trading. Automated trading bots are agents that perceive market data, make buy, sell decisions. and execute trades. Asterisk robotics and manufacturing. Asterisk robots on an assembly line perceive parts, decide on actions, and manipulate them. As a developer, building an agent is about structuring your code around that perceive think act loop. Here's a simplified pseudocode idea. Python. Class simple agent. Def _ init _ self. Environment. Self. Environment equals environment. Def perceive. Self. Hash get information from the environment. Hash e.g. sensor _ data equals self. Environment. Read _ sensors. Hash e.g. email _ inbox equals self. Environment. Check _ emails. Return sensor _ data hash or email _ inbox. Def decide _ action. Self. Perception. Hash implement your agent's brawn here. If perception, temperature, greater than 25, return turn _ on _ AC. Elif perception, motion _ detected, return send _ alert. Else, return do _ nothing. Def act. Self. Action. Hash execute the chosen action. If action equals turn _ on _ AC. Self. Environment. Activate _ AC. Elif action equals send _ alert. Self. Environment. Send _ notification. Motion detected. Single quote. Hash. Other actions. Def run. Self. While true. Perception equals self. Perceive. Action equals self. Decide _ action. Perception. Self.act. Action. Hash optionally. Add a delay or sleep. This structure makes your code modular and focused on the agent's behavior. While powerful, agents come with challenges. How do agents learn? What if multiple agents have conflicting goals? How do you test and ensure the reliability of complex autonomous systems? The future of agent-based AI is exciting. We're moving towards * multi-agent systems, where many agents collaborate or compete. Think self-driving cars coordinating traffic. Integrating agents with advanced AI models like large language models, LLMs, can give them incredibly sophisticated brains for decision-making, allowing them to understand complex instructions, generate plans, and even communicate with users in natural language. This unlocks a new era of highly intelligent and adaptive autonomous systems. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.